We've got 5 types of reactions, guys: synthesis, decomposition, single replacement, double replacement, and combustion. All right, so you have that information in your reference packet. Have those out. Have that sheet out I gave you yesterday. I'm going to write some things down, guys. Today, this is where it all comes together. We're going to learn how to predict products. And that is where this sheet really comes in handy. Again, you have it in your reference packet. It's on every test and quiz that you will have from here on out, as well as your final. So we're going to use that sheet, guys, to help us predict products. You've got to be able to determine what products will form when you're given only a set of reactants. All right, so doing these problems, we're reviewing everything we've done up until this point. It's the best review we can do. You're naming, you're balancing equations, and you're also identifying the types of reactions. Now, before we can predict products, guys, what do you think is the most important thing we have to identify before we can actually predict the products? Say louder. What type of reaction, guys? Even more important than getting a formula, even more important than balancing, because we can't balance an equation until we have products to balance both sides. So we have to figure out what type of reaction it is first. All right, and that is where that chart comes in handy. So here's our process. This is nowhere in your notes. You should write this down somewhere on page 9 in your packet. This is kind of the steps, guys, you'll need to go through to write out a complete equation. From here on out, the rest of the school year, you need to make sure that you always have a balanced equation, whether you're given reactants or you're given the whole reaction. Make sure you know it. So, first things first is you got to write the formulas. That means going from the name to the formula, if possible or if needed. Sometimes they'll already give you the formula. That makes it a little bit easier. Okay? Use the crisscross method, folks. Don't be too lazy. Again, I'm seeing it all the time that we're not having the right starting materials or we're having issues balancing because we don't have the right formula. Don't be too lazy to take the extra 5 to 10 seconds to actually write out your ions and then crisscross them over so you know you have the right one. If you have prefixes, you don't have to do the crisscross method. But if you don't see prefixes in the names, you've got to use the crisscross method every time. Once we have our formulas, guys, then we identify the reaction type. All right, that's where that chart is going to come in handy. Once we identify it, we will split our compounds. How do we split compounds, guys? Back in Unit 5. How did I teach you guys to split compounds? Draw the line, right? This is where we're going to draw the line. And how do we know where to draw the line? We're going to draw the line before the second capital letter, which really, guys, means the second element. That's really what we're talking about. When you get to a new element, that's where we're going to split it up into what comes first always. What ion comes first always? The cation always comes first. The anion always comes second. Once you identify it and you know what pieces you have, then we're going to switch partners or we're going to break them down depending on what type of reaction we have. And then the last step, guys, we're going to balance the equation. All right, so I can talk at you all day about it. The only way we're going to actually start to figure it out is by actually jumping in and doing some practice. So this chart is what we're going to use. It's going to help us out. It's got all 5 types, guys. It's got general equations. There's a lot of different ways. Some of you guys may find a different method. Some of you may need to go a little bit more. Find the way that works for you. You've got to be able to predict products. That's the big thing. Again, when we come back to stoichiometry after break, that's where this all comes to a head, guys. Units 5, 6, and 7 all in one. All right? And stoichiometry is the backbone of chemistry. Without it, we're going to struggle the rest of the year. So, let's just dive right in, guys. It's page 9, number 1. We got to identify what type of reaction it is first. When you see this element, guys, as a reactant, is it always combustion? No, but right away you're thinking it's what? You're thinking it's combustion. Now, last week, guys, with the demos, I didn't do the demos for you guys. You want to do a demo today? Yeah. So when you see oxygen, guys, it can be combustion. That's kind of what you think first. But a combustion reaction, we look back on the page before, has to have a hydrocarbon and oxygen. What makes up a hydrocarbon? Hydrogen carbon. Do we have that here? Absolutely, guys. This is a combustion reaction. There's another one that we will see next week. I'll do this for you, where it's magnesium and oxygen. Is that a combustion reaction? Not really, guys. This is a synthesis reaction. It forms MgO, and then we can balance it out. All right, so once we identify and we know we have a combustion reaction, because we have a hydrocarbon and oxygen, your products are always the same. That's the simplest one to predict the products, because they're always what two compounds? They're always carbon dioxide and water. So we just write them in. CO2, H2O. Does it matter which order we write CO2 and H2O? It really doesn't, because of the plus sign. Typically, you'll probably write it like that, because it's just the order that it gives it to you guys, but it doesn't matter. Go ahead and balance this equation. What are our coefficients going to be when we balance this? 1, 3, 2, 2 is what you should have. All right, when you balance this out. That's it, guys. Combustion ones are pretty easy to predict products because they're the same every single time. All right? But just because you see oxygen, don't assume it's a combustion reaction. It's going to be with a hydrocarbon as well. All right, let's go on to another one. Number 2 says barium plus copper 2 chloride. What's the first thing we have to do? We got to write the formulas, guys. How do we write barium? Ba plus copper 2 chloride. So, do we see prefixes there? No, so we got to use what method? Crisscross method. Copper, what's the charge on copper? How do we know it's 2 plus? Roman numeral tells us. Chloride, what's the charge on chloride? -1. When we crisscross it, what's our formula? CuCl2. So those are our reactants. Now, this is where we're going to have to go back to our table and see what we've got. So, if we take a look, guys, synthesis, A plus B yields AB. Is that a possibility for ours? Could be, okay. Decomposition, AB. So what do we start with, guys, with the decomposition? You always have what? One reactant. Is that true of this reaction? No. So we know it's not a decomposition reaction here in number 2 because we have more than one reactant. Again, in my opinion, it's the easiest to eliminate. Can it be single replacement? It could. Could it be a double replacement? Why do you guys say no? Right, because we have an element right here, guys. Barium is an element. This is a compound, but we have an element plus a compound, which means what is it? It's going to be a single replacement reaction. Now, another way, guys, that you can think about it. When you see new elements in your reactants, you can assign them a letter. So I would say A for barium, it's the first one, plus B, C, right? B for copper, C for chlorine. And notice, guys, where there's a plus sign, that means they're a single, that's where you're adding those together. But if there's no plus sign between the letters, that means it's a compound. So you can see the general equation, A plus BC, and you can match it up right here. Oh, look. There it is. A plus BC. Find the way that works for you. This is a huge resource. That's why this is one of the easier units of the year, because you've got so much information, guys, on this table, on this chart. So now, to predict products, if we go back and we look at this, A, it says pairs with C, and then B is by himself. So if you write your letters out like I did, it makes it very easy to see, okay, A is going to go over here with C, and B is going to be by himself. So what's my new one going to be? Okay, BaCl. Can we assume they're going to have the same subscripts on both sides? No, guys. Now, when we balance equations, the subscripts never change. But when we predict products, the subscripts can change because it depends on what they're bonded to. So we've got to go back and check our crisscross method to make sure we have the right subscript. What's the charge on Ba? 2 plus. Chloride we said was 1 minus. So is it going to be the same this time? Yeah, it will be this time. But it may not be the same every single time. Don't assume they're going to have the same subscripts when you're predicting products. And then what's going to be by itself? Copper. Balance the equation. What'd you say, Kennedy? It's already balanced, guys. Sometimes it works out like that. All right? I'm proud of you. Look at that. See? There it is. All right. So, guys, sometimes it's balanced. That's okay. So here's our final answer right there. Now, we've got to take note, though. Next to single replacement in your packet, in your note section, guys, we have to use this thing called the activity series. Add that to your notes. I'm telling you, you should be writing that down. If I'm writing it down, you should be writing it down. When we have a single replacement reaction, we have to use what's called the activity series. Well, the activity series, guys, is right there. So page 15 in your packet, very last page of your packet, you're going to want to write that definition down where it says, what is the activity series? It's a table. It represents the ability of different elements to replace other elements, and it's dealing with a single replacement reaction. We only use it with single replacement reactions. So, this activity series, guys, you are given this on every test and quiz. Again, it's in your reference packet. We've got two different ones. We've got one for the halogens, and we've got one for metals. All right? So again, halogens, that's that special single replacement halide-halide reaction that we saw back here on the types of reactions right here, guys. This one down here at the bottom. All right? So, the ones that are more active are to the top. So most active are at the top. I want you guys to write this in your blue reference packets. Most active is at the top. We increase as we go to the top of our chart. All right, so the higher up on that chart, the more active it is. In order for a single replacement reaction to occur, you have to have a more active element coming in to replace a less active element. All right, so for example, going back here to barium and copper. Those are our two ones. Barium was the one that's coming in to try to kick out copper. Well, if we look at our activity series, we've got to look and see where they are. I've got barium is right here. Copper is all the way down here at the bottom. Will this reaction occur? Yes, it will, because barium is more active than copper. All right, it's higher up on the table. Now, folks, you'll notice this top section, all right, where this arrow goes right here. Okay, you'll notice these elements are the ones that are the most active, guys. They can replace hydrogen from cold water. So if you were to have like a dish of cold water and you threw those elements in there, they would replace hydrogen, meaning they would react. All the elements below that would not react with that cup of cold water. The elements here with this arrow, the first two sections, they are active enough to replace hydrogen from steam. All right, so what is steam? It's gas what? Water, right? So it's H2O in that gas phase. So now it's not cold water anymore, guys. It's hot water, and it's not liquid anymore. It is gas. Those elements can replace hydrogen when it's in the steam form. The top three sections, they can replace hydrogen when it's mixed with an acid. And then basically every element, guys, on this activity series can react with oxygen to form oxides except for silver, platinum, and gold. Why might that be important for us, that silver, platinum, and gold don't react with oxygen? Because what? They don't corrode, right? But where do we use those three elements in particular a lot of times? Some of you may have it on you right now. Jewelry, guys, right? The real stuff, gold, silver, and platinum, it's not going to corrode, it stays. Have any of you guys ever had like a ring or something on that like turns your hand green or blue? No. Right? That's not pure. All right? It might be coated in silver or gold or platinum, but it's made of copper. All right? Because it's that bluish color that copper gives off. So that's how you can tell if your jewelry is fake or real. If it discolors your hands, it's oxidizing, so it's not actually one of those three. Question. This is how we use our activity series, guys. Let's do some practice there on page 15. I've got potassium or sodium. We've got to figure out which one is more active. Potassium's right here toward the top. Sodium is the last one in the top section. Which one's more active, folks? Potassium. Why? It's higher up. Let's do the next one. We've got chlorine or iodine. Chlorine, right there. Iodine is the bottom of the halogen series. Which is more active? These should be gimme points, guys, on your test on Tuesday. Finish this section on page 15. Another example Another example, guys, with predicting products. What's the first thing we have to do? ID the type of reaction. So that's where that chart in your reference packet will come in handy. What element do I have right here? So what might it be? Might be a combustion reaction. Is it going to be one though? No, because this is not a hydrocarbon. So we've got an element, guys, plus an element. What type of reaction is going to be? This is a synthesis reaction. All right? So we got to predict our products. What's my product going to be? What method do I need to use? They're coming together. Use the crisscross method. Ca, what's the charge? 2 plus. Oxygen is a? What's my formula going to be? Why is it CaO and not Ca2O2? Reduce them down. What's our last step we got to do? Balance it out. How can I balance this? Put a 2 where? There's my final answer, guys, right there. Your homework this weekend is to finish. You're going to finish page 9, the prediction. We already did the activity series. You have a quest due Sunday at midnight.